extremely small hydrogen bubbles which are swept off by the flow. Most of these bubbles are small enough so that they follow the flow quite accurately. A few large bubbles are also formed. We ignore them in observing the flow pattern. Here you see a probe with multiple thin fingers which makes many fine lines. Another kind of probe is a single wire with sections insulated so that we see bands of bubbles coming off the probe. The third concept we need is the timeline. A timeline is defined as the instantaneous location of a line of fluid particles marked earlier at a prescribed location in the flow. These lines are usually most useful if the marking location is normal to the flow direction, since then the location of the timeline, a short time later, shows the velocity profile of the flow field. Here we apply the timeline technique to a steady flow past an airfoil. Near the angle which gives zero lift, the portion of the timeline passing above the airfoil rejoins the portion passing beneath at the trailing edge, except for the narrow boundary layer region where the flow is retarded by friction. Since the distance around either side of the airfoil is approximately the same, the timelines show that the average speed above the airfoil is approximately the same as beneath it. When the airfoil is set at angles which give large lift, the portion of the timeline passing above the airfoil outruns the portion beneath. The velocity is higher near the upper surface. At negative incidence, the effects are reversed.